So hi. First, I'm going to start with an apology. I deceived you. You thought you were coming here to hear about Fetch API. I have to go back to my notes because I'm anxious. You thought you were here to hear about Fetch API. But actually, this is a lecture about coming of age, about a language becoming more mature. And through the story of Fetch API, we will learn how Node.js grew from being just a little runtime baby environment to what it is today, with all the rich features and everything in it. So through this journey that we're going to go through, in the end of it, we will learn how Fetch API did happen. In your face, Regina George. And now I'm going to do a very Regina George thing, and I'm going to talk about myself. So my name is Shirly. Currently, I'm a Python developer in a company called Falcor, and please don't kick me out because I really, really love JavaScript. JavaScript was like my first language I worked with, and I really love it to the bone because it has everything I love, and Python is not very far away from it in terms of like philosophy and stuff, and I really, really like it. And also, I'm a master of starting hobbies and not finishing them and never mastering anything. So master of all, master of none. So let's begin our journey. To understand what is Fetch and why did we need it, we're going to go back to 1999. This is like the pre-Fetch life. The pre-Fetch life started in the front end. In the front end, we had XHR, XMLHttpRequest. It landed in 1999, and it invented by Microsoft. Microsoft needed a way to communicate between Internet Explorer and the server. So they created the XHR in order to do this communication, and this was the first time we could send a request from front-end to back-end, from browser to server, using JavaScript, which was pretty intense at that time. It was pretty cool. But as we will see in a minute, XHR, it was using like some really outdated, like currently speaking, using some really outdated approaches, callbacks, event listeners, and for this reason, it was usually wrapped. In the old days, it was wrapped by $get of jQuery, later by $HTTP, and today, most of us probably using Axios. But to be honest, Axios today is using Fetch behind the scenes, so that's I needed to take it out of the table. So this is how XHR code looks. It's pretty hard for us to read it today, right? Because this is not how we usually write code nowadays. We have async, await, and those callbacks and event listeners. It kind of messes up the code, and that's a lot of lines for calling, like to generating one request. So then Fetch was born. Fetch was born in order to make it better, to make it easier for us to send requests from browser to the server. And it was invented by WG. WG stands for Web Hypertext Application Technology Workgroup. And that's a bunch of people from Google and Mozilla and Apple and Opera that decided to form a group to make the web browsers better through standards and tests. Like let's take the browser and bring it to us, the developers, and make it better for us. And they came with the idea of creating the Fetch API. So the Fetch API is pretty cool. It landed in 2015, and it's a promise-based API, so we can use async await with it and write better looking code. It has request and response objects, which allows us to manage better our requests and responses. Especially the response object is pretty cool because it allows us to intercept requests, fetch requests, and return the values that we want using this response object. And it also, in the frontend, supports a user-controlled cache and no cores out of the box. This is how fetch looks. Oh, no. OK, this is how fetch looks. We are sending a response. We are waiting for it to come back. We are getting the response data, and we're console logging the data. This is like more clear than XHR could ever be, right? So it happened. And now let's talk about Node.js, because it's 8 minutes already into the talk, and I never said a word about Node.js at all. So Node.js had the same exact problems with request HTTP. Kind of outdated JavaScript approaches, usually wrapped by a package like Axios, request, and node fetch. Please remember this one for like 2 minutes, because 1 year after fetch landed in browsers, the community created Node Fetch, which wrapped the Fetch API for the server. Let's take a look at how it looks. Kind of the same, right? Callbacks, event listeners. And looking at this code, we're feeling like, OK, we have Fetch API in the browser. We can make it better, right? We have everything we need. Just make it work. Well, that wasn't so easy. And it took 7 years. 7 years? Right. It took 7 years for a reason. For 2 reasons, actually. The first reason is, should Fetch API even be Node.js? Well, I don't know. Why shouldn't it be, right? But let's make the question a bit broader. What should be in Node.js at all? Like, if you're looking at the definition of Node.js, Node.js is an open source, cross-platform, JavaScript backend runtime environment. But what should be inside it? If you're like Ryan Dahl, 2009, standing in front of this big empty board, and you think, what should we put in it? So let's start and do like some sort of countdown. Do we want JavaScript in Node.js? Like, well, it's in the name, it's Node.js, JavaScript. We should put it there. And what about basic backend interfaces? Do we want HTTP, DNS support, a file system, things that we never had in web because they were irrelevant? Yes, we want it. We want them because without it, the Node.js won't be a mature backend runtime environment. What about web APIs? Like BOM element, DOM elements, get attributes, stuff like that. Well, it's a web stuff. We don't want those. So what about set timeout? Do we want set timeout in Node.js? Just a second, sorry. I mean, yes, because set timeout is pretty essential. You can't imagine our lives without set timeout. OK, so let's look at the standards. I'm going to Google it in my mind. And OK, set timeout, OK, web API. Wait, what? Set timeout is a web API. It's not like part of JavaScript. Yes, it's not part of JavaScript. This is a web API. I was really surprised when I first heard it. And I hope you're surprised as well. So yeah, from the beginning, we had web APIs inside Node.js. But then the question arose, and do we have to put all web APIs inside Node.js? Probably not. So what will be our guidelines to decide what should be inside Node.js? So the guidelines that the Node team decided upon were small node core. The philosophy is that Node comes like no battery that Node should not come with batteries included. That means if you want something, and it doesn't have to be like a core feature of Node, you should build it on your own. For example, Node Fetch was the community saying, we want Fetch to be inside Node. So we built it ourselves with some limitations because they couldn't do everything they wanted. But this was the philosophy. And I think it's a smart philosophy, right? Because if the core was getting bigger and bigger, it was hard for the Node team to deliver us cool feature that we wanted. And, it's hard to maintain a large code base. But this started to change. If you're looking at Node today, in Node today we have just a few examples. We have promise timers. Promise timers, like set timeout in a promise, is not a very core feature. We have test runner. I think any one of us can think of at least 2 test runners that exist in NPM. And parse args, a module for parsing command line arguments. Those stuff are really, really not core. So there's no more Node core. Why did that happen? I don't know. I tried to snoop around, to look in the internet, and there wasn't a clear answer. So I have there are 2 possible answers. One that I heard of and one that I thought of myself. The first one is, well, things get mature. Sometimes when you get mature, you don't forget, but you realize that you have to give up some of your principles that you had as a child, and that philosophy was a little by little thrown out. The second reason, possible reason, is Node had a little new brother, Deno. And Deno had this cool thing that it was new. It could do whatever it wanted. And it didn't have this pressure and burden from the past to deliver things. It was unexpected. And in a term, it was like every time Deno did something, the community came to know, and they were like, why can't you be more like Deno? Deno is really cool. And so this competition caused Node to try to be more web compliant, to insert more features, and they always be on the same level. And once Node.js started to be more web compliant, it was easy to say, okay, fetch should be in there. So this was the first phase of why fetch didn't make it so fast into Node.js. The second phase is, let's make fetch happen. Let's take a look on the fetch API again. We are seeing that. Looks pretty simple, right? But underneath, there's a lot of stuff that we don't see, which are pretty cool. So the first thing that we don't see here is the fact that response body is a string. If you were in Benji's and Robert lecture before, you heard about it a little bit. So this is the stream. When you console log the request body, you see it's a readable stream. What is this readable stream? I don't know. Streams are the ability to take something big, break it into small chunks, and deliver them piece by piece without loading the entire thing into the application. And there are 3 stream types. We have the readable stream, writable stream, and the transformation. The readable takes something big and reads it in small parts. The writable takes a big thing and writes it in small chunks. Transformations do transformation. And those streams that were used in fetch can also be used to create chains. Like, let's read something big, do a lot of transformation in the middle, and then write it somewhere after all the transformations without loading everything into our memory. So Node.js had their own stream implementation, but Fetch was using another implementation, the WebWG's implementation. And it's not like the WebWG team were like, yeah, we're going to do something else on purpose. Node.js had something. WebWG created their own thing because they were they're responsible for the web. They have nothing to do with Node.js. And then WebWG invented Fetch API, and they were like, okay, we're going to use our thing. So in order to be web compliant, the Node team had to implement the WebStreams, which are very, very different from the streams that implemented in Node. And actually, they're even lacking performance in comparison to the Node.js streams. But those streams were introduced in Node 16.5, and they're still experimental as the fetch feature. And this is how it's used. We are creating a stream. In line 4 to 9, we're creating a new stream, streaming stuff out. And then in lines 11 to 13, we are reading the stream and doing things with it. This one is not like the best example because we have the entire thing inside inside our memory, but it could be in the same way it could be like streamed from another server. So this is one thing that took time to implement. And also it's kind of a compromise, right? Because there was already streams inside Node.js, and now we have 2 different streams implementations in Node, which is like not the best thing, but also a part of a language, of an environment getting bigger and older, that you have to do these compromises. Another cool feature that Fetch is using is the ability to abort requests. Fetch requests can be aborted, and it uses 2 new interfaces. It's also what WG's invention. We have the abort signal and the abort controller. The signal is passed to a promise, and when the signal is on, the promise is being cancelled. And the abort controller is controlling this signal. The signal can abort the request and the response. So if you have a request that's running and streaming into your code, you can send the signal. So you're already reading the response, and it will stop. Once the signal is activated, the stream will stop and will send an error. And also, you can use one controller to control many requests. So if you have one request that's calling like 3 other requests, you can cancel all of them like in one line, one command. So this is how it looks. Sorry that it's so big. On this side is the request, and there over there is the abort. In line 9, we are sending the signal. Okay, wait, I will go line by line. We are starting by creating the controller. We're sending this in line 5. In line 5, we are creating the controller, we are initializing it, and then we are getting the signal out of it. Then in line 9, we are creating the fetch request, and we are passing on the signal. And as you can see on the right side of the screen, this is the abort. It's only like controller.abort. Once you're calling that, the request is throwing an error, and it stops handling, and that's it. It can also be used for another kind of promises, not only fetch, but it's pretty cool. And it was graduated to stable in version 15, and it was it was not only created to support the fetch API and compliant to the web, but it was part of being more web compliant because this is a very major web API. Okay, so now we made fetch happen, but with some sort of asterisks because some things were not implemented. Origin header and course are not so relevant to the server world. Request caching. In Frontend, we have request caching supported by the browser. In Node, we don't have that. There's no place that the request object can be cached. So it wasn't implemented as well. And also, the server doesn't have cookies because there's no sense of one user to the server as there is in the client. Okay, so now the fetch is happening. We have the fetch in Node 18. It landed. It's still experimental, so you can try it and see how it works. But a few weeks after it landed, there was some really cool thing that happened in the runtime environment world. This thing is WinterCG. WinterCG stands for Web Interoperable Runtime Community Group. And it looks like WG, like if you just by looking at it, right? And that's exactly what it is. WinterCG was invented out of the notion that the web has its own thing, that its own community that creates the standards for the web. And we can see that it does good. The front end, the web world is very, very mature, and it has a lot of new initiatives. And in some way, it dictates, the WG kind of dictates where the Node.js world and the JavaScript runtimes world is headed as well. So the WinterCG group were like, we want it as well. So it's built of people from Node.js and Deno and Cloudflare workers, and they're saying, we are going to do our own stuff to make the runtimes environment better, to evolve things, to bring innovation. And they're not coming against the WG, they plan to work together, which is pretty cool, and I think it will get us to very good places. And it really connects to this lecture because this is what they're working about. First thing they're working about is which subset of fetch API should be implemented in the runtimes. So they're discussing that and trying to understand what should be inside there. Second thing is the minimum common web API. All the JavaScript runtimes, what should they implement in order to be standard runtime environment out of the web APIs? So this is also pretty cool because if all the runtime environments will implement the same standards, we can jump from Node.js to Deno like seamlessly, like we do today in some sort of way between browsers. So this is pretty cool. And also, they're working on stuff that are not really relevant to the front-end world. For example, web cryptography streams. In the front end, they probably don't need streams, cryptography in streams. So they will also evolve stuff that are only relevant to backend, which is also pretty cool, and I think it will take us to nice places. So, to sum things up, I think this is a great time to live in terms of JavaScript environment development world, because we are kind of in the middle of things that are happening. The process is still going, and things are getting more mature as we speak. And I think we have a lot of influence if you want to influence on one side, and if you don't want to influence, we are getting a lot of stuff like for free by having a lot of environment runtimes that competing with each other, but also bringing each other up. And I think it's nice to have it, and the world, like our world as web developers and backend developers, will improve as a consequence of these things. And I can't see what the future holds like in terms of JavaScript environments. Thank you.